Hi there, I'm Miss Sundquist. Welcome to my mock 8th grade classroom. Today we're studying physical science, specifically chemistry. And our topic of the day is atomic structure. So you may wonder, what really is chemistry? What do chemists do? You might have an image of a chemist working in a lab with bubbling test tubes and exploding experiments, but what really is chemistry? Well, it might surprise you to find out that actually everything is chemistry, because we're all made up of chemicals. I'm made of chemicals, you're made of chemicals, the floor is made of chemicals, this board is made of chemicals. The computer you're working on is definitely made of chemicals, and even your dog's spot is made of chemicals. So what do chemicals look like, and how do they form? Well, that's a big topic, because that's really what chemistry is all about. But today I hope to introduce you to a little bit of the building block of chemistry, which is atomic structure, and the different identity of atoms, which are located in the table of the elements, the periodic table of the elements. So let's get started, shall we? So I want you to pull out your notebooks and take notes, okay? First, we're going to look at the formation of an atom, how an atom is structured, okay? So if I were to take a really powerful microscope and look at some matter, let's say I were to look at my hand, and I were to drill that down on that microscope and look at the very building blocks of matter in my hand, past the tissue, past the cells, the blood, everything, I would get to an atom. So an atom is our basic building block structure for all of chemistry and all of life. And what does that look like? So let's see. So I want you to write in your notebook the atom, okay? And it's A-T-O-M, okay? And the atom, and I want you to pull out a couple of different colored pencils because we're going to draw a picture of the atom. And so I'm going to use pink and blue and orange. Those are my colors. So the first thing I want you to do is draw a circle. Now this is the center of your atom, and it's called the nucleus. So you're going to make a little arrow, and you're going to draw the word nucleus. N-U-C-L-E-U-S. Okay? Now the nucleus is composed of two types of particles, and this is where you get to use your colored markers or your colored pencils. Okay? The first one is called the proton, P-R-O-T-O-N. And if you want, you can even make a couple of dots in there. Okay? Now interspersed with the proton, I'm going to use orange for this one, is the neutron, N-E-U-T-R-O-N. And the neutron, you're going to intersperse, so all the pink doesn't go together. They kind of move around, and we'll talk a little bit more about that later. But we have our neutrons. So we have two types of particles in our nucleus. We have the protons and the neutrons. All right, now you're going to pull out a third color. Okay, next we have a cloud of fast-moving particles that are moving so fast we really can't tell where they're located except by calculating a probability, like perhaps where they might be. And these are called, and they're very tiny in comparison to the mass of the proton and the neutrons. And these guys are called electrons. So you're going to write a cloud, a circle around that, and these are E-L-E-C-T-R-O-N-S, electrons. Okay, like I said, they're moving really fast, And they're pretty far away from that nucleus, actually, when you look at the distances of these tiny, I mean, we're looking at microscopic, nanoscopic sizes. And so relation to the nucleus, these electrons are very far away, moving very, very fast, so fast you can't even tell how fast they're moving, and you don't know where they are, and they're very tiny. Okay, so everybody got that? You've got a nucleus with your protons and your neutrons, and then around that, a fast-moving group of electrons. Okay, now one more thing. These particles, so protons, neutrons, and electrons, have kind of flavor, okay? What I mean by that is that electrons are negatively charged, and we're going to designate that with a minus. So they're negatively charged particle, okay? Protons, so if you know the word pro is positive, so these guys have a positive charge. So you can write a plus next to those guys, okay? Neutrons are neutral. They're kind of the Switzerland of particles. They don't really get involved either way. Electrons and protons are attracted to each other, but neutrons are neutral. They're just sort of like the good friends who just sit in the middle of other friends who might be arguing with each other and just, you know, not being affected by anything. So those are the neutrons. So N-E-U-T-R-O-N, neutron, and they're neutral, okay? So we don't really usually have a little symbol for them, but just know that they don't have a charge, okay? So everybody clear? We've got our atom, our nucleus, proton, neutron, and electrons. Okay, so that's what an atom looks like. Now, are all atoms the same, you might ask? Well, no, they're all unique, just like you guys. Except that there are a certain number of types of atoms. And we can tell which types of atoms we have, sorry about moving around there, by the numbers of protons, neutrons, and electrons that each atom has. And these types of atoms are found in our periodic table of the elements. Now, you've probably seen this in your textbooks. We have a whole really interesting table with all these symbols. Well, each one of these is a specific type of atom. So, what can you tell about these? Well, each one has a symbol, so you have to learn the symbols and the names, and we're going to actually memorize that at some point. But today's just sort of an introduction. So let's start with the simplest one, and then I'll talk you through this as we go. Okay. So let's start with hydrogen. You might have heard the term hydrogen. Hydrogen is a very volatile gas usually. In fact, some of you, have you ever heard of the Hindenburg? It was a big dirigible that was filled with hydrogen gas, and it exploded when it was coming in on its arrival in the 1930s. So hydrogen is a highly explosive, and it's usually natural state found as a gas, and we have hydrogen in the air. Well, let's look at hydrogen and the structure of a hydrogen atom, okay? So, and I'm going to kind of talk through how you read a periodic table at the same time that we do this. So, okay, so we're going to start with our hydrogen atom. A hydrogen is first in line, and it has an atomic number, and I'm going to write these down. So the next thing I'd like you guys to write in your notebook is atomic. Let's write first, we're going to do hydrogen. So it's H-Y-D-R-O-G-E-N, okay? And then I want you to write underneath it symbol, and that's H. That's first number, okay? Now, it's atomic number, so that's the next thing I want you guys to write down. Atomic number is 1, okay? It's first on the list, okay? Next, we're going to talk a little bit about these numbers that are on these cards here. We're going to talk about its mass. Do you guys remember what the mass of something is? Yeah, it's kind of like the weight, although weight is a little different than mass. It's pretty much similar. So let's just talk about the mass. So the atomic mass, okay, is always going to be found on your periodic table with several decimals after it, okay? And in this case, it's 1.0080, okay? All right. Okay, so let's look at what that's going to look like when we look at the atom. So we're going to go back to our structure. So a hydrogen atom, and you're going to want to draw this on your notebook next to all your information on hydrogen. Okay, you're going to have a nucleus, and you're going to have this out here for the electron. Okay, so let's talk through this. The atomic number always equals the number of protons and electrons. Okay? So what that means, let's move that there. So what that means is that the atomic number equals 1, and it equals the number of protons and electrons. So we know in hydrogen that 1 is the number of protons and 1 is the number of electrons. So we have 1 proton and 1 electron. And that is how we know we have hydrogen. Any atom that has 1 proton and 1 electron is a hydrogen atom. Okay? Does that make sense? Now we're going to work through a couple more. Now, neutrons. Neutrons are a little trickier, but we're going to do a couple examples so you guys get the hang of it. Okay, neutrons. So the number of neutrons equals the atomic mass minus the atomic number. Okay, so let's talk through this. Make sure, did everybody get that written down all right? Okay, so we'll talk through this. So ATM, my ATM stands for atomic. It's an abbreviation, okay? And you can write it further down. I ran out of room, but if you need to write it on in your notebook differently, that's fine. Okay, so the atomic mass of a hydrogen atom is 1.0080. Now, for calculating neutrons, let me say this a couple times. Just round to the nearest whole number. So just round to 1. So you don't have to copy out all the decimal points, okay? Just go to 1. So we're going to round up. So we're going to take the atomic mass, which is 1, okay, minus the atomic number, which is 1. And I'm sorry about being all crammed in there. Okay, and what does that equal? 1 minus 1? What's 1 minus 1? 0. Okay? So like I said, we don't have any neutrons. Actually, I didn't say that, but we don't have any neutrons. We know that a hydrogen atom has 1 proton and 1 electron, but we don't have any neutrons in a hydrogen atom. Okay? That's very unique. It has 1 proton, 1 electron, and whenever you have that, it's hydrogen. Well, that was hydrogen. So what if you want to look at all the other elements in the periodic table? Well, all you do is add protons and electrons. So if you have 2 protons and 2 electrons, you get helium. If you have 3 protons and 3 electrons, then you get lithium, and on and on. Well, we've run out of time here, but I'm really glad you could join me in my classroom, and have a great day and look forward to seeing you again. Bye-bye.